Fellow geometers and seekers of general truth, let us approach a question here with really little information and see how we can solve it, okay, and then extract some additional information from this. So in the figure below, the measure of CD is equal to 103. Find the measure of EF and explain your reasoning. Well, let's look at some things here. First, when we say the measure of an arc is the same thing as the measure of the central angle. Okay. So the measure of CD being 103, that's like saying that this angle here must be 103 degrees. Okay. And then we're told to find the measure of EF. So that's like asking, what is the measure of this angle right here? Okay, because remember, again, it's the arc measure is the same thing as the central angle. Okay? And from this picture, it would seem that we're kind of stuck, but we actually have quite a bit of tools at our disposal. So one thing that we can use here is the fact that all of these radii are equal, right? So CA, DA, FA, and EA are all equal to each other. And then we're told that these two chords happen to be equal to each other as well. Okay. So now you can see that this problem is practically done. We just need to write up all of the details. So let's write up all the details. We can say that AC, that red line right there, must be congruent to AE. They are both radii. Next, we can say that AD is congruent to AF. For the same reason, they are both radii. Okay? And finally, we can see that CD and EF are the same because it's given. So these three pieces of information, when we combine them together, tell us something pretty useful. Namely, it tells us that we have a two triangles that are congruent to each other. Okay? So that's quite a powerful and useful result, I think. So those three pieces of information, we can add on to our, we can combine them here into a flow proof, and we can say that the two triangles, CAD and the triangle EAF, are congruent to each other by side, side, side. And therefore, angle CAD must be congruent to angle EAF by CPCTC. And since the measure of CAD is 103 degrees, the measure of EAF, this angle that we've been looking for, must also be equal to 103 degrees. Okay, and that is our answer. Now maybe you want to jump to that conclusion right at the beginning, but it is really important to flesh out all of the details here. Okay? Because otherwise we don't really know, we're just sort of making wild, blind guesses. So now this leads me to a theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So let's draw a picture of a circle, and let's have a chord here. Let's call this chord AB. And let's have a second chord here. Let's call this chord CD. And what this theorem says is that arc AB is congruent to arc CD if and only if line segment AB, right, so we use this bar here, is congruent to line segment CD. So let me make this clear. This should be an arc. Okay? And if you want to see a proof, well, we did it up here. Okay? So this is saying that if the line segments are the same, right, if these two distances are the same from A to B, from D to C, then the two arcs here must also be the same. Right? They don't have to both be vertical, they can both be slanted, these two line segments, but as long as it is true that the arcs are congruent, then the line segments must be congruent, and vice versa. Alright, so we'll end this video here. We'll start another one in the next video that talks about some other types of theorems. As always, thank you for watching, and have a wonderful day. Oh, I'm sorry, before we go, let's name this theorem here. Let's name this the congruent arcs and chords. And chords theorem. Okay, congruent arcs and chords. Now,